So finally, let's take a look at some chemical equations that represent chemical reactions. So first off, do you see, I think I must have three here because I see three sets of boxes. Do you buy this that we have two reactants, okay, R, and we have one product, P. And notice that also we have some physical phases. L stands for liquid, gas, and solid. So can you see where, and sometimes I call it a brick wall. Here's my brick wall. But do you see where new substances are formed? Clearly, new substances are formed, right? So as I have it here, this is what we call an unbalanced equation. Now, do you see where I have now revealed the little boxes, and we'll be talking more about this because I want you to kind of have a sense for it. But now I have a 6 in front of the Cl2, and now I have a 4 in front of the PCl3. Now, usually students are pretty good with this. Now, I don't have anything here, and actually you probably buy this. This is what we say implied, the number 1. Those big words are called, it is a big word. Those big numbers to the left of the reactant or product are called stoichiometric coefficients. I abbreviate it stoich-coef. Okay, so stoichiometric coefficients are 1, 6, and 4. So let me right quick kind of show you what that means. And actually by placing the right stoichiometric coefficients in front of the reactants and products, you have what we say balanced it. And what I mean by balanced is if I put a brick wall here, again, to separate our two reactants from our one product, and if I were to count phosphoruses, I'll put my P over here, count phosphorus atoms and chlorine atoms, and phosphorus atoms and chlorine atoms on the product side. Okay, so I keep asking, do you buy this? But so this subscript 4 means I have 4 P's and I only have one of that repeating unit. So do you see where actually the number of phosphoruses I have is 4? Now, this 6 means we have 6 Cl2 units. So if each Cl2 unit has 2 Cl's and I have 6 of them, you buy that? Okay, so that's the tally on the reactant side with those stoichiometric coefficients. Let's look at the product side. Now, this 4 here actually applies to this entire unit. So we have 4 P's, and we have 4 times 3 Cl's, or 12 Cl's. So when we talk about balancing, that's all we're trying to balance. And like I said before, we have the same number of atoms of each type of element on either side of the reaction arrow. Are new substances formed? Yes. And we represented it here now as a balanced equation. I don't think I'll necessarily do that for all of these. But now, this next one, we could, but let's see. We have 2 reactants and we have 2 products. That is an unbalanced equation. So I'm going to go ahead and reveal the stoichiometric coefficients, and you could confirm, in fact that sounds like a good question, a good quiz question. Go ahead and confirm, I'm going to put my brick wall here, okay, go ahead and confirm carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. I want you to tell me, let's see, which one do I want? I want you to tell me how many oxygens there are. Question mark oxygens. There are. Now it's balanced, so you know that we have the same number of oxygens on both sides of the reaction arrow. The last one, oh, it looks a little tricky for this class. So we aren't going to necessarily get to something quite like this, but with the stoichiometric coefficients of 1, 6 for those 2 reactants, 2 and 3 for those 2 products, actually we have the same numbers of each type of element on either side of the reaction arrow. I've got a couple visuals to kind of go along with that idea. So if we go with coefficients of 1 across the board for everything here, so I have a 1 here, 1 here, 1 here, and 1 here. And is it balanced? And you would say no. And we could kind of look at a visual sort of deal. And if we count, for instance, hydrogens, those are the little white orbs, just visually speaking, if we have one of these and one of these, we have, what, 4 hydrogens over here and 2 hydrogens over here. So no, it is not balanced. So if we go ahead, and I think this actually was an example I had on a couple slides ago, if we go ahead and change the coefficient in front, stoichiometric coefficient in front of the O2, if we change that from a 1 to a 2, and if we change the stoichiometric coefficient in front of the H2O from a 1 to a 2, now we actually can see visually. Now we're talking. Let's check everything if you want to. Just by the white balls, we have 4 over there, 4 over here. Those are your oxygen atoms. No, I'm sorry, your white balls are your hydrogen atoms. We have 1 carbon here, 1 carbon here. We have oxygen in red, so we have 4 here, and we collectively have 4 over there. So yeah, it's balanced now, and that's what that's kind of showing you. So in physical science, I just think this is so cool. We have a lot of conservation this, conservation that. Basically, I guess it falls under conservation of energy and conservation of matter. So what we do when we make sure that we have the same number of atoms of each type of element that we start with and we end with those same number of atoms of each type of element, that actually is an application of the conservation of matter during ordinary chemical reactions.